Now, dear student, chapter number 12, and the topic we have that is Ohm's law, resistance and the factors on which the resistance of a conductor depends, and the resistivity, that is called the specific resistance. Already we have made the discussion, but just I am just making the whole the discussion in the part of a single lecture. Okay, so we have discussed, and generally this law is given by the German scientist, that is George Simon Ohms, and he took the series of the observation of the current and the voltage by applying the potential difference across the various conductor, and he expressed them in the form of the law that is called the Ohm's law. Okay, so he generally state that current, and we are just representing it by the symbolic notation that is called the I. Current is flowing through a conductor is directly proportional to the potential difference across the ends of the conductor at constant physical conditions like area comma length comma temperature and pressure. Okay, so this is the basic concept of the Ohm's law we have, and already we have discussed further. We are just I am showing in front of you, as I is directly proportional to the V, so we can easily that V is directly proportional to the I, and we are just making the concept of that V is equal to, that is R is the constant of the proportionality we have, so we are just using the V is equal to Ri, or you can use the V is equal to IR. So this is the part of the Ohm's law we have. So this is the one of the basic equation we have in the sense of the Ohm's law. V is equal to IR, and each alphabet having its own symbolic notation. Now what is the meaning of the V? We have potential difference, potential difference, I is current, R is the meaning of the resistance of conductor which we have used. Okay, so we have the basic formula that is of resistance, that is R is equal to V upon I. So this is the second portion we have, first and the second we have. Now what is the relation between the V and I? Now V is directly proportional to the I. So whenever we are just plotting the graph, so we can easily write that you are using the V on the y-axis and taking the I on a x-axis. So easily there is a relation, V is directly proportional to the I. Somehow you are just making the slope of the graph, that is called the theta. Now this is the I, this is the V we have, and the same type of the graph we have, because the V and I having the linear relation, this is the slope of the graph. But here we are just saying that V is directly proportional to the I. So whenever you are just able to learn the trigonometry, so we will discuss this one term. Okay, so this is the basic relation between the V and I we have. Now, what is a possible diagram that we can use to demonstrate the Ohm's law? So, I am just making the simple abbreviation. Now, one of the cell we have, okay. We are just using the ammeter in the series combination. Then, after across the ends of a conductor, we are just using our end of the resistor. We are using the voltmeter in the parallel combination. Now to change the magnitude of the current, we are just making the concept of the rheostat. So automatically that without keeping the change of the voltage, we are just getting the meaning of the resistance. Okay. Now it is also called the variable resistor also, and the meaning of the current we have in the circuit. Okay, as we are just approaching the close key. So this is the one of the basic circuit diagram we have. Now we want to discuss the meaning of the resistance here, with the concept of the unit also. Okay, so the next topic we have the resistance, and even we can use the basic concept of the unit also. So generally the resistance measure in the part of the ohm we have. Okay, so unit concept we have in the Ohm's law formula. Unit we have, that is called the ohm. It is called the ohm. Okay, that is equivalent to the potential difference having its unit, that is called the volt, and divided by ampere. Okay, so here we have the basic that mean unit of the resistance, that is called the ohm. And how can we define the concept of the 1 ohm? So we will start the this one topic here. So generally we are just talking about the resistance, or as we are just using the basic concept that we are just taking the part of a conductor in which the flow of the electron is there from the negative side to positive side of the battery. Okay, through the portion of a conductor. So whenever the electrons are making the that means movement through a conductor, so the atoms and the ion of a conductor obstruct the path of the that means flow of charge. Okay, flow of charge. So that impact comes in the form of the resistance. Okay, and resistance offers the temperature to a conductor. So the heating of a conductor or the wire should be, they will be there. Okay, this is the part plus minus we have. Now we are just meaning the approaching of the current in the circuit, and somehow there is a or in the another manner we can say that the electrons are making the collision with the atoms and ions of a conductor. Okay, so generally the resistance is a property of a conductor to resist the flow of charge through it. It is denoted by the symbol R. We are just using the meaning of the resistance by the R. So it is a property. I think I am audible to you as per my knowledge. Okay, so easily you can understand the concept. It is a property of the conductor. Property of the conductor. It is the property of the conductor to resist the flow of charge. The flow of charge through it. Flow of charge through it. It is denoted by the symbol R. It is denoted by symbol R, and we are just using the concept, that is R is equal to V upon I, that is called the potential upon current. Okay, so up to this you can understand the symbolic notation that V upon I what regards. Okay, so generally we are using the unit of resistance, unit of resistance, that is called the ohm, and ohm can be regarded as ohm, that is called the volt upon ampere, volt upon ampere. So easily we can define the 1 ohm, define 1 ohm. So how can we define the meaning of the 1 ohm? So one of the general define we have of 1 ohm, resistance is said to be 1 ohm if potential difference across ends of a conductor is 1 volt and the current is flowing through it 1 ampere. So this is the basic define of the 1 ohm we have. Okay. Now one of the basic information we want to make from the formula, that is R is equal to V upon I, as we are just stating that I is equal to V by R. Okay, so we can easily see it that resistance, that means current flowing through a conductor is inversely proportional to the resistance. Current is inversely proportional to the resistance. Okay. Second one is that current is directly proportional to the potential difference. Okay. Now the third parameter, if you are just making the change in the resistance, so automatically there is a there is a impact on a conductor, impact on the electric current we have. Now if I is equal to V upon R, and we are just implying that R dash is equal to 2 times of initial value of the R. So the new current we have, that is called the I dash is equal to, without changing the meaning of the voltage we have. So this is the new current we have, and we are just approaching R dash is equal to 2R. So we are just easily saying that if you are just increasing the meaning of the resistance, so the current will be the half of its original value, that is I by 2. Okay, so this is the one of the basic that means change on the formula we have. Okay, somehow we are just making the change in the voltage. Okay, we have the general basic relation V is equal, I is equal to V by R, and we are just making the change of the potential, that is V 2 times of the initial value. So the what will be the meaning of the new current we have without changing the meaning of the resistance R. Okay, so V dash is equal to 2V upon R, and we are just getting the new magnitude of the current, that is called the I dash is equal to 2 times of the I. Okay, so these are the general variation we should learn from this formula. Now we will discuss some of the physical condition or the factors those affect the resistance. Okay. Now the first variation we have, for a wire of given material, the resistance of conductor is directly proportional to the length L as area is constant. We are just keeping the concept of the area is constant for this variation. So easily we can say that the resistance is directly proportional to the L. Okay, so if you are just increasing the L, so the electron having the more striking to the atoms and ions of a conductor, so it will that mean experience the more opposing, that mean by the conductor. Okay, so there is a more opposition to the flow of charge in a greater length. Okay, so this is the first variation we have. Now we are just assuming that for a given for a wire of given material, the resistance is inversely proportional to the area of a conductor. Okay, as the length is constant. So we are just assuming in the part of the mathematics, that is R is inversely proportional to the area of cross section of the given wire. Okay. Now the third point we have to be included here. Now next we have resistance depends upon the nature of material of a conductor. Okay, of conductor. Now the fourth point which we want to include here, and the directly fact you must learn, that resistance is directly proportional to the temperature. Okay, as we are just increasing the temperature, so the resistance will also increase. Okay, or the resistance will increase, so the temperature of a conductor will also increase. Now we are just approaching the attention towards the two mathematical concept, that R is directly proportional to the area, and R is inversely proportional to the cross sectional area. Now this is the equation number 1 we have. R is directly proportional to the L, and R is inversely proportional to the area. And we are just using the equation number 1 and 2, and we are just mixing the two parts, that R is directly proportional to the L upon A, and we are just removing the proportional sign, and we are just using the constant of proportionality. Here we have, that is called the symbol, that is called the a rho, that is called the resistivity, and here we have the, that is R is equal to rho L upon A. Okay, now here we have used the one of the basic formula, that is R is equal to V upon I. Now we are just making the new formula of the resistance in the term of the length of a conductor and the cross sectional area. Okay, so here we have the new constant, that is called the rho, and it is called the resistivity, and it is called, or it is called the specific resistance, specific resistance. Okay, so this is the part of the that mean constant we have. Okay, so easily we can go with the concept. Now the resistivity rho, so we are just separating the formula. Rho is equal to R into A upon L. Okay, so here we are just assuming that resistivity or specific resistance of a conductor is equal to resistance R when a conductor having area 1 meter square of length 1 meter. So we are just approaching this one concept. So the resistance of a conductor is called the specific resistance or the resistivity we have. Now we will talk about the unit concept. Okay, so the unit of the resistivity, unit of rho, that is equal to resistance having its unit, that is called the ohm, and the unit of the area is called the meter square, and the unit of the length is called the meter. So we are just cancelling it, so we are just getting the finalized unit of the resistivity, that is called the ohm meter. Ohm meter is the unit of the resistivity we have. Now resistivity of a conductor throughout the volume does not change because it's a type of a inherent property, and generally we are just saying that it does not depend upon the physical condition of a conductor. Okay, so as we are just changing the length of a conductor or the area of the conductor throughout the volume, it does not change. Okay, so for whole the material, if the element is very small or the big and made up of the same material, so all the time the resistivity will be the same. So this is the important point about the resistivity we have. Now we have the formula of the resistivity. Rho is equal to R into A by L. Suppose cross sectional area of the conductor which is given to us. Okay, so we are just using the concept that pi r square. Suppose in the sense of the diameter we have that, so we are just using that pi d square by 4. So this is the part of the variation we have in the formula. Okay, now the next variation of the formula, that is r into pi d square by l into 4 we have. Okay, so we can make the change, so the certain formula we will get here. Okay, so on behalf of the part of the variations we have. Okay, r is equal to rho is equal to r into a by l. This is the one of the type of the formula we have. Even rho is equal to r into pi r square upon l, and rho can be stated also in the term of that rho is equal to r into pi d square by 4. Suppose the diameter of the wire is given, and we are just using it directly, so we can use this one formula. Okay, the next general point which I have included here, SI unit of the resistivity is ohm meter, or either you are just writing in the symbolic notation, that is ohm meter. So this is the all about the concept of the resistivity. Now in the next lecture we will discuss some of the numericals on behalf of the concept of the resistance and resistivity.